Hello and welcome to Best Practices for Change Data Capture in Scylla. I'm Kalle Wieland. Let's get to it. What is Change Data Capture? Well, your data on disk is a topological view of your application. Change Data Capture is a temporal one. It is a log of modifications as they happen to your data. It captures the changes, literally. And then you can asynchronously read them back and consume them and do whatever you want with them. Use cases include transaction analysis, fraud detection, Kafka pipelines, or duplication or mirroring of your data, or any other thing that you can think of. It's your application. How does CDC and Scylla work? The feature can be enabled per table, and the log itself is actually just another table, which is stored distributed across nodes in your cluster, with rows ordered by timestamp and modification order. Columns are mirrored from your original table for the pre-post image data or the delta images, and every record contains the modifications and the TTLs of the data being written. The CDC log topology matches the source table data. It's partitioned to be co-located with the base table data to ensure that you get equal data consistency. The data in the table is transient, where it's by default TTL to 24 hours, but this is configurable. This is mainly to reduce the risk of uncontrolled metadata buildup. Now, when you normally write into a SQL table, you send SQL to a coordinator node, which processes it and then creates RPC calls to the replica nodes where data is actually stored. Writing to a CDC-enabled table is the same thing. You send SQL to the coordinator node, but the call gets intercepted. Here it gets pre-processed, and we optionally issue pre-image reads to get data for pre- and post-image generation. Now the CDC mechanism will piggyback writes to the log table created from the original mutations on the same write calls that goes to the replica nodes. So we don't generate more writes, but we do generate more data. Every mutation sent to a CDC log-enabled table generates one or more rows in the CDC log table. You can have pre-image data, which represent the state of the row as it was before the change, the row keys, and the changes to the non-key columns, the delta as we call it, and optionally also a post-image, which is the state of the full row as it is after the change. Every CDC log write uses the same consistency as the base table write, so it has the same guarantees. There are of course downsides. If you're using pre- and post images, you are issuing reads before writes, which introduces latency. And you are always generating more data. You're writing to two tables. So there is a performance cost. The CDC log itself is eventually consistent like everything else in Scylla. And every concept of change in the CDC log is as viewed from a client view, as data seen by the client via the coordinator. And it doesn't contain any information about how the state of the cluster might actually change the perception of data at a later point, as it only contains information about what was written. And there's always a risk that you get a partial log if a node crashes. Now to consuming the data. The CDC log is read through normal SQL. It's after all just a SQL table. The data is replicated but already deduplicated as you read it through the normal SQL mechanisms. Every piece of data, the delta images, etc., it's normal SQL data, and you can consume it without knowing anything about how things work under the hood. The core functionality is very simple, but it allows you to build more advanced things on top of it. A CDC log is partitioned into what we call streams. This divides the token ring space of the cluster, and every stream represents a slot in the token ring. This is the partition key of the CDC log table. When you're reading from the CDC log, you can read from all the streams, one of the streams, or some of the streams. This gives you the opportunity to round-robin traverse the token ring of data. This is very useful because it allows you to read the CDC log without doing cross-node queries, which is, as you know, expensive. It also allows you to view a single partition group at a time and get a more clear timeline view of the data. The CDC streams available can be queried from metadata system tables. Now this will change if a cluster topology change happens, because this changes the tokenization of the original data. This means that data written into the log after the topology change will be using the new streams, whereas the old data will be using the old expired stream IDs still. Data in a single stream is clustered on the original mutation timestamp as a monotonically growing time UUID. This to be able to differentiate writes to the original table that used the same timestamp. As you can see, CDC events in any stream depends on the source data distribution. So if you have changes to different points in the tokenization of the base table, you will get a different number of events in the CDC log based on the same tokenization, i.e. the streams. And when you query from the CDC log table, the CQL sort order will give you a view that might be similar to this. You first get the data from one stream where you have monotonically growing timestamps, then you get the next stream, and then you have again monotonically growing timestamps, but only within this single stream. So you need to be aware of this when you're reading from the CDC log. Timestamps in a CDC log can be used as either paging markers or watershed markers for repeated queries into the same stream. But again, you need to take into account the fact that timestamps are only monotonically growing within the same stream. If you do a cross-stream query, you will get this. Let's look at some examples. For this simple demo, we will first create a key space, and then a table with CDC enabled, but without pre and post image. Let's then insert some data. These are the data columns inserted, and this is the CDC log generated. As you can see, you get the timestamps, the batch sequence numbers, metadata columns, TTLs, which are not in play here, and you get the CDC operation, which is important. In this case, it was inserts. And you get the delta data actually written. Let's insert some data with a TTL. As you can see, inserting data with a TTL includes the TTL in a metadata column in the CDC log. This is also a good example of how you can use timestamps to do paged querying. Here I select only the rows which. Now let's enable pre and post image. And then insert some data. And look at the log. As you can see, the log rows generated by this operation now includes the operation itself, the insert, but also a post image, the data as it was written. Because I generated new data, there is no pre-image. But if we do an update, you can see that I also get pre-imaged information. One thing to note here that you can see that the column I1 is not included in the pre-image. Why is that? This is because I have pre-image set to the default mode, which only includes data included in the actual modifying operation. In this case, we didn't change I1, so it's not included in the pre-image. It is included in the post-image though. If we change the CDC options to instead have a full pre-image and do the same update, we can see that we now get a pre-image data column for I1. If we want to delete the column value, we get a log that looks like this. You have a pre-image, you have the delete operation, which sets the column in question to null. And then you have a post image where the column, unsurprisingly, is null. A row delete, on the other hand, will look like this. You have a pre-image, which is the data as it looked before this change, and then you have a row delete and no post image because the data is gone. Now let's look at some advice on how to query CDC data efficiently. Streams are your friend. Do your queries per stream in a round-robin fashion across the token ring. Avoid cross-node queries. These are slower than normal queries or non-cross-node queries. And use timestamps to page across several queries if you can. This is a very useful technique. Be mindful of topology changes. When the stream set changes, you need to query the new set and start querying this as well. And you have timestamp information when the stream set becomes available, so you have a switch over time. Take this into account. Timestamps are your friend. Use them to page between queries in a single stream. Use them to limit the data that you're looking at. Look at data from an hour ago. Look at data that is newer than X or older than Y. And remember the max time UID, mean time UID functions that allow you to use time from a client's point of view and create watershed marks for time UID partitioning. Normal SQL practices applies as well. Use the appropriate consistency levels when reading, balance, throughput and consistency. You have Scylla monitor metrics available for CQL as well as CDC metrics. Use this to profile and balance your querying library. We will be providing integration libraries. These are higher level CDC libraries for consumption and integration, including examples. Libraries for Java and Go are already available in preview form on GitHub. Python library is coming, and Kafka integration library is also coming. The takeaway from all this. CDC and Scylla is easy to integrate, it's easy to consume, it's plain SQL. It's very robust. It's replicated the same way as normal data, there is no bells and whistles, there's no weirdness involved, and the overhead is very reasonable. You use coalesced write to the same replica sets. Overhead is basically adding a second table to your writes. And it does not overflow data if the consumer fails to act. It's TTL'd, you will not kill your cluster with it. As a comparison chart, here you can view some of the competing database solutions and their CDC offerings, and you can see that Scylla ticks all the boxes. We're great. Going forward, CDC is already GA in Scylla 4.3. Additional features will come in Q1 of 2021, and moving forward, we will continue to add performance, we will continue to add integrators. We will bring this to Scylla Cloud. It will be available to you without any local administration, and you will also see alternator streams, which is our DynamoDB compatible API for CDC. I hope you enjoyed this presentation. If you have any questions, reach out to us. Join us on GitHub.